Hello, everyone. Today is Wednesday, March 23rd, and this is the Cluster API office hours. As always, please follow the meeting etiquette. If you would like to speak, please raise your hand. I will make sure you get to talk. And then if you have any topics you'd like to bring up, you can add them below under the agenda discussion topics. If you don't have access to the document, you can join the SIG cluster lifecycle mailing list in order to get edit access. All right, and I guess let's get started. If you haven't already, can you please add your name to the attendee list so we can get an idea of who's attending these meetings? And I guess before we get started, if there's anyone here who hasn't been to this call before and wants to kind of just say hi and introduce themselves and tell us a bit about why they're here, now is a great time to do so. So I will mute and let people go ahead and introduce themselves. And Tobias, looks like you have your hand up. Go ahead.
Yeah, perfect. Thank you. Hi, I'm Toby, and some of you might know me already from Slack or Cluster API provider OpenStack. I'm working as a software engineer at Daimler TSS, which is a subsidiary of Mercedes-Benz. And I would like to take the first point, the open proposals readouts, because we want to introduce our proposal about Cluster API state metrics, which is an additional component that creates CARPy-specific metrics. And it's mainly inspired by Cube state metrics, and it creates metrics, obviously, for the state of CARPy resources like clusters, machines, machine deployments, and so on. Yes, and like introduced in the previous CARPy office hours from Christian Slaughter, we will migrate the existing repository, which is currently located under the Mercedes-Benz organization in GitHub. And we want to migrate it to the experimental observability directory in the core CARPy repository. Yes, and we already created the proposal and linked it in the document here, and everybody is welcome to review it. Yeah, that's it.
Awesome, thanks. So I guess, oh yeah, it's here. Okay, cool. All right, is there anyone else who wants to say hi?
Yeah, hi, I don't know how to raise my hand on Zoom, sorry. This is Pierre Benetti from Runhat. I'm working on installing OpenShift and OpenStack. And I am here first time as we're trying to increase our presence upstream and trying to contribute and do good things upstream.
Awesome, welcome. Anyone else? Karthik?
Yeah, hi everyone. So I'm Karthik. I'm contributing to the cluster API provider IBM Cloud. So yeah, great to be part of this and start contributing here as well. Thank you.
Welcome. Ryan?
Hi everyone, I'm Ryan Bezchek. I work at Twilio. I just started, so I've been spending most of my time in multi-tenancy Kubernetes, and they are doing some cluster API work here, so I'm just kind of here to listen in.
Cool, great to have you. All right, I don't see any other hands raised. Is there anyone else who wants to say?
Yeah.
Oh, go ahead.
Yeah, I'm Abhishek Agarwal, software engineer at DataCore. So I'm working on OpenEBS project, which is like an open source container attached storage. And yeah, it's my first time. I'm just trying to like get into this cluster API and make some contributions. Thank you.
Welcome. Great to see all the new faces. All right. Anyone else before we move on? Cool. Okay, so I guess, yeah, I skipped the proposal readout. Should have started with that, but let's go to the open proposal section. And instead of going through each of them, since there are a lot, I'll just let folks who want to give an update raise their hand, and we can discuss each proposal, unless you already have a topic below, in which case we can get there when we get there. So do we have any updates? Oh,
I'll go. Yeah, I just want to, thanks, Cecile. I just want to plug machine pool machines. I think we're at the point where there's general agreement on everything. I made some updates. Specifically, we realized that there's going to be some implementations of machine pools that are never going to be able to delete individual instances. So this remains so we had the idea that maybe everybody's going to have to implement this, but there's obviously a couple cases where it's going to remain optional. And then came up with a way to not carry around the infrastructure reference list on the machine pool, but instead use a selector, as Stefan was suggesting, and I finally figured out a way to do that. So those are the major changes. If people could have a look at it, I think we're pretty close to agreement, but I would love to hear what you guys think. That's all.
Thank you. I will definitely make sure to take a look this week. And yeah. All right. Any questions for Matt on machine pool machines, the proposal, or anything like that, or any comments? All right. Any other proposals that we should pay attention to besides the state metrics one that was already introduced? All right, I don't see any hands, so I'll move on in that case. Let's head into discussion topics. Stefan, you have the first one, go ahead.
Can you give me co-host?
Yeah, you're actually already co-host. I made you co-host at the beginning.
Perfect. I'll just overwrite yours, I guess. Should have worked. Okay. So you should see my Chrome. Okay. Yep, so we have a new proposal and I just want to give a short introduction. So some context. We currently have a proposal open for runtime SDK, and we recently implemented cluster class and we implemented inline patching. And the goal of this proposal is to extend cluster class and build on top of runtime SDK to provide a way that folks can use external patching. The idea with external patching is instead of having to write JSON patches in your cluster class, you can implement a component, and we are calling that component, and it returns us patches. I would just go, let's say, on a high level over the document. And then, yeah, just would be nice if folks can react if they have time. So the main motivation is basically that inline patches are not powerful enough. So we're using JSON patches. We have some limitations. You can just embed them in YAML. You have a lot of YAML. You can't unit test them. You can't release them separately. So that's why we want to provide an extension point, essentially, that folks can implement them in whatever program language they want. They will get the templates from the cluster class and all the variables, and then they can just generate patches, JSON patches or JSON merge patches in whichever way they want, and unit test their business logic, etc. The goals of the proposal is mainly to define that extension point, to document when exactly it is called, provide some guidelines how they should be developed, and define essentially how you can plug in external patch extension in the cluster class, so how you can enable them. So that's the main topic here. I wouldn't go over the use cases. Very, very high level from a runtime SDK perspective, you would deploy it more or less like that. So you deploy your external patch extension as some kind of deployment with a service, etc. Then you can register it by deploying an extension CR, where you just reference where it is running. In your cluster class, you can then reference the extension here by saying, okay, you have all your patches, you have inline patches and external patches, and when you have an external patch, then you can reference your extension. You can order them, you can use internal and external patches side by side, and eventually all those patches, internal and external ones, are combined and will result in a cluster. Yeah, developer guide also. Won't go into details, but rough idea here, just from a high-level point of view, when we're looking at a cluster topology reconciliation, we get some event on a cluster, then we get more or less the current state, we compute the desired state here, and then we have our patch pipeline today. So today we're only generating inline patches, and with that proposal, we are still generating inline patches, but generating external patches as well. And we also have a validating hook, so that when an extension generated some patches, they can in the end validate if they actually achieve their goals. So if, I don't know, if they want to inject in registry, then at the end they can just take another look at the final objects and figure out if if it's still there, or if there was some other patch or inline or external patch which just overrode those changes. I think that's probably enough for a high-level point of view. So the rest of the document is just some details, how to develop them. We also have some Swagger specs, so some OpenAPI specs here in Swagger. So if folks want to take a closer look how requests and responses exactly look like, etc. Yeah, I think that's all I want to cover.
Thanks, Stefan. Do you mind for all the new people here giving a bit of context on like what cluster class is and how we got here?
Yep. Just one. Okay, yeah, do it freeform without any kind of proposal in front of me. Okay, so how did we get there? Cluster API until roughly version 1.0 was that when you created a cluster, you had to define all individual objects by yourself, more or less. So we have cluster templates, so it's a little bit easier to generate them. But in the end, you had to define a cluster object, a kube-ADM control plane, when you use kube-ADM, infrastructure, machine templates, machine deployments, all that stuff. And when you create a second cluster, you have to do it all over again. And it gets tedious over time. If you have 50 clusters, you have to all your resources 50 times, and it gets really hard to manage. So one major thing that cluster class solves is that you can define the shape of a cluster class just once. So a cluster class is a collection of templates, and now I'm maybe really showing some YAML to make it a bit easier to grasp. I hope we have an example in the cluster class proposal, but I think so. So nowadays with cluster class, it's still an experimental feature, by the way. Where's the YAML?
Maybe you can look at the example under the end-to-end test.
Yep, that's a good one, thanks. Okay, perfect. So nowadays, when you define a cluster class is a collection of templates. So you define that cluster class here once. You still have to create your kube-ADM control plane, but the difference is now you do it only once in a cluster class, and you won't do it for every individual cluster that you create later. So you have your kube-ADM control plane template, your corresponding Docker machine template, you have your infrastructure cluster, in that case a Docker cluster, and you define let's say the shape of machine deployments. So in that case, you have a default worker machine deployment, also based on kube-ADM config on a specific Docker machine template. When you scroll further down, then you have all those templates. When you now create a cluster, and I'm not sure if you have an example for that. Oh, we actually have. I wasn't sure if it was kind of generated. Okay, so now when you create a cluster, you won't have to create all that YAML again. You just reference the cluster class I just showed, and it will use the templates from that cluster class to instantiate your class, essentially. So we have that topology reconciler, which takes the cluster class, which takes the information from the cluster, and it will generate a kube-ADM control plane, a machine deployment, etc. for you. And if you want to create a second cluster, you just take that YAML here, change the name of the cluster, and you have your second cluster. You don't have to create the templates again. The next step to that is you can parameterize your cluster, because of course not every cluster looks the same. So some basic variables is like you can define how many replicas your control plane should have. So we have a control plane replica here. If you want to have more machine deployments, you only have to create another array element here. That reference goes to that machine deployment class here. So you can create just 5 machine deployments, all based on that shape, but with different replica counts, with different labels, etc. Taking this one step further, so the replicas, the workers, and we also have a version field here, by the way. Those are built-in parameters, but that's probably not enough. So one example, I don't have AWS, so I use another example. So let's say you have different clusters, they should use different registries. What you can do then is you can define a variable in your cluster class, so image repository here. When you create a cluster, you can, yeah, it's actually here. You can just set the image repository or another one, and then that will be used. And the variable will be used by taking that value here and modifying the templates of your cluster class for that concrete cluster. And currently, the only way to do that is by defining JSON patches here. So essentially, you take that variable value and patch a field in your cube-ATM control plane in that case. Was probably a pretty short crash course, but what I should definitely show is documentation, especially for new folks. So
hold on, we have a question if you don't mind.
Oh yeah,
Matthew?
absolutely, just ask.
This looks kind of similar to other tools that run client side, like Customize, for example. Yep. Is this are we implementing Customize as an operator here?
No, I think the difference is that we have domain-specific knowledge that we can build on top. So I think the best example is probably the version field. So if you change the version field here in the cluster, then what our topology controller will do, it will upgrade all parts of your cluster in the right order and will make sure that it actually works. So it starts with changing the version in the cube-ATM control plane. Then the controller will wait until all your control plane nodes are upgraded. And after that is done, we will upgrade the first machine deployment. And after that is done, the second machine deployment, et cetera, et cetera. And you can still do that with Customize if you want, without cluster class, but you have, I guess you need some kind of logic to orchestrate that update, for example, to make it really work smoothly. There is no single field where you can just change your version of your whole cluster. So that's one thing. I guess the other part is with having the patches here, it's still probably relatively close to just doing Customize on the client side instead. Apart from that, it's actually done on the server side. But I think external patches will make it way more powerful because you can deploy your components at runtime, which can get data from wherever you want to and just generate those patches. So for example, you can do things like implement an external patch, which calculates the right OS image for you based on in which AWS region you are, based on which Kubernetes version is used, things like that. And then publish that somewhere and reuse it across cluster classes. Yeah, things like that. So it's kind of related. But I think if you want to do the same things with Customize, you have a lot of additional logic that you have to put somewhere to make it work. Does that help?
I think I'd have to read it a little bit more.
Yeah, and I guess the discussion is a little bit more detailed. We had one like that on, I think, the proposal PR.
I just wonder if perhaps because Customize is very good at the substituting values. You'd already have JSON patches, for example. I wonder if the other bits of the logic, like waiting for the version, can exist in the operator while the substitution parts don't. But again, I may have to read it more. So I'm going to read it.
Yep, I think the answer is probably that cluster class is doing multiple things, and one thing is more or less templating individual clusters, and the other thing is having a high-level picture of your cluster lifecycle and managing that too. And I'm not sure if you can do that part without cluster class. Maybe theoretically, but not as it's implemented. But definitely the pointer to read up on more stuff we have here in our book. Under experimental features, cluster class, a lot of different documents which describe how to write a cluster class, how you can use it to operate a cluster, et cetera, et cetera. So that should definitely help. And, we can definitely discuss that again and go into much more deeper details. I know there were a lot of other arguments in the last discussion we had about that.
Awesome, thanks. And so just to link that to the current proposal, like the new proposal, mutation hooks. Can you like expand on what, you know, what's missing now and what the proposal is trying to solve?
Yep, what the proposal is trying to solve is that you, let me show the YAML and the proposal. So what we still have, even with external patches, is the variable definitions here. So which schemas those variables have, at least in the first iteration. And what we're trying to solve is that that you have to define all those modifications to your clusters via JSON patches. The problem with JSON patches, just go over that again. So if you have a bunch of variables and have a lot of logic, I mean, you end up with a lot of YAML that is very, very hard to read and very hard to test. So one thing is we want to move essentially that logic here into testable Go. I mean, it depends on which language folks want to use, but in code which can be unit tested and released, etc. Instead of just, hey, let's try to do end-to-end testing that all those patches with each other actually lead to our expected results. Yeah, then yeah, I think that's, I already mentioned that part, but you can't really just release an individual patch and reuse it in class, something like a logical thing. Like, I don't know, I want to be able to inject an HTTP proxy into a cluster. You can copy paste it around in a bunch of cluster classes if you have several, and then do end-to-end testing, but there's no way to write clean code and unit tests, etc. for it, and then just use it by referencing that implementation. Yeah, that's already mentioned that. You can't reuse it across cluster classes because you have to embed it in every one of them. Then another limitation, you can't use any external data. So that JSON patch here is just, I mean, the only input it has is the variable that the user provides, but you can't do anything else. And we had requirements like when, I think that was a vSphere example also, that when you have a cluster in a specific Kubernetes version, then you want to be able to, then you want to have something which can figure out the exact name of your operating system image automatically. And for that, you have to ask, I don't know how it works in vSphere, but the vSphere API, the AWS API, etc. You can solve that in other parts, and I'm not super familiar with the vSphere example. But yeah, with external patching, you can use whatever you want as data source. Cloud APIs, other CRDs, if you have some reason for that. Etc.
Awesome.
Yeah,
thanks.
and yeah, last one is just you are limited to JSON patching. So one major thing that we know, I mean, you can do, we can't allow add, replace, remove here. You have a path, of course, and you can have various ways to define variables, like hard-coded or from a variable or a little bit of code templating. But for example, it's not possible to have an array variable and then append an array to an array. That even that doesn't work with JSON patching. And there are probably a bunch of other ways, a bunch of other things that you can do, because you just have that simple JSON patching here with a little bit of templating on top. Yeah, but that's it.
Thanks for explaining the context and taking the time. Do we have any questions for Stefan about the proposal? All right, feel free to read it and add comments and questions in the doc if you have questions that come up. All right, back to the notes. Fabrizio, you have the next one.
Hello, everyone. So talking about another proposal, the runtime SDK proposal. Runtime SDK proposal, first of all, thank you to everyone provide the feedback. Hopefully all of them are addressed. The proposal is out since some time now, and the comments are kind of stabilizing. So what I would like to check with you today is if we can set a lazy consensus for getting the proposal merged, given that feedback are addressed. I also added an error management session as required by Cecilia, if I remember well, and some other notes about discovery or runtime extension as managed, who was asked by Alberto, if I'm not wrong. So the proposal is almost ready. we are starting to prototype on it in a branch on Stefan fork. And this proposal is provide a foundation for the topology mutation hook that Stefan just described. And also we are working on another proposal with Kilian Yuvaragi that is defining a set of lifecycle hooks before upgrade, after upgrade, and so on and so forth, that will be super useful for the add-on management story, and especially for the move of the CSI out of tree. And yeah, given all this reason and the fact that the runtime SDK is behind a feature gate that by default is off, we would really like to start writing code and merging it in main. So yeah, if there are no objection, we should really set a basic consensus for runtime SDK.
Thanks, Fabrizio. I haven't had a chance to look at the error stuff that you added yesterday yet, but I'll take a look. To me, that was the main thing that was missing. I also saw there was a comment from David, I don't know if David's here, about the use of WebAssembly, and that seemed like it was unresolved last time I checked. I don't know if that's something we should talk about further. But
no, the comment is just if we can describe in alternative the possibility to use WebAssembly. It was already there, and I also tested, but then discarded the option for two reasons. One is a security reason, because basically if you run WebAssembly inside your code, basically WebAssembly get the same security context that your code gets, which is pretty powerful, being cluster API. Instead, if you run an external extension, basically it is up to the administrator to create a security account with the only limited scope, and that's the most important reason. Second reason why I discarded WebAssembly is that currently the Golang support for WebAssembly is really limited, and in forcing people to start using new languages like I don't know, Rust or whatever can have a huge impact.
got it. Cool. David, are you here? Did you want to say anything? Oh, sorry, you have your hand up. Go ahead.
Thanks. Just to throw it out, CPython now works in WebAssembly as well as Ruby, and so the tooling side. So if the choice is about the tooling side, the dev side, this stuff's moving pretty quick, and it'll probably get there. Well, I mean, it's going to get there. It's probably going to get there sooner than later. From the security side, is there anything that stops us from having a role an account for the web binding as opposed to the controller itself? Seems like that would be feasible. And the idea that now that you take another dependency on another service, that just increases your failure rate. So the more services you depend on, the lower your nines go, right? So just as we take more dependencies on external systems, we have more variability on how they'll react and how our system reacts. So that's all I was calling out there. I appreciate y'all listening.
Yeah, kind of makes sense. I also experimented with WebAssembly. I know well people working on KubeWarden, and yeah, there are pros and cons. When we decided following the cluster API webhook pattern was the safest and the most the the most well accepted in the community. So we went down this path. Maybe in future we can have both, but yeah, I don't see a big problem, but yeah, we have to start somewhere.
Well, I guess maybe we can comment on the proposal about the lazy consensus so that people who aren't in this call can also, be informed and objective needed.
We'll need it is okay end of next week.
I mean, let's comment in the PR and let people, give them a chance to object, but it's okay with me. And what else? Oh yeah, I was also going to ask, I know there are a few security, not concerns, but things to, point out and have mitigations. Does this have any impact on the security, like the SIG security assessment of cluster API? And if so, should we involve those folks to review the proposal as well?
I can talk with Pushkar, if I remember well. I can talk with him and ask. I don't think so, because basically from cluster API itself, things does not change. Then you have another component with its security context and yeah, but yeah, let me talk with Pushkar.
Sounds good. Any questions or comments before we move on? All right, and Fabrizio, you also have the next one.
Okay, so this week we got a report of an issue about managed topology, so cluster generated from a cluster class. And this issue basically highlights a problem when we have a CRD with a slice, which is co-authored both by the topology controllers, that means it is derived from template, and from another controller. The example, just to make this concrete, is the bring your own subnet in the AWS cluster, where in the template you put the ID of the subnet, and then the controller goes and fill in all the other detail of the subnet. That means that this slice is kind of co-authored by two controllers. And so now it is this use case is creating a problem in cluster class, because basically two controllers fight for controlling the slide. The problem is that okay, we are investigating the problem, looking at possible solution, but the fact is that our CRD are not designed for this. It does not work even with kubectl, because in order for kubectl to allow two managers to edit the same list, you have to add some annotation like list type map or list map key. So it is kubectl can decide basically which person can override what, and so what I'm asking to the community here is that please help us to understand if there are similar use cases, so a list that is partly edited by the users and partially edited by controllers, so we can better assess the problem and figure it out solutions.
I think Azure cluster subnets might be the same thing from memory, but I'd have to check.
Okay.
Winnie?
Yeah, so question, I just started reading this issue. So I see that there is a workaround, but without the workaround, does it mean that creating AWS cluster with cluster class is not working, or it's just like these two controllers, Kappa and Kappa controllers, keep patching? Which is
exactly. Without the workaround today, the two controllers fight for the same object, and one set one value, the other set the other, and the other restore the value, and so on and so forth. So they keep fighting for the object. It basically doesn't work. And yeah, so this is why I'm trying to understand how big the problem is, and we have to figure it out. But at the end, it will boil up that if we don't add a notation to our CRD, like a list type or list map key, basically we don't know how to get the element of the slice, merge them together. I'm going to add more detail on the issue, but currently our CRD are not designed for this. And yeah, we have to figure it out, how to solve it.
Okay, thank you. Yeah, I will should bring this to attention to Kappa community also.
So I'm not sure how this works in Kappa, but at least in Cap Z, I think, and I think it's similar, the information that's put in by the controller, like from the existing subnets, it's not really mandatory, it's purely informative. Like it just fills out the details about the subnets, CIDR ranges and stuff like that. But then that doesn't get used anywhere. So it's almost like a status, but it's being put in the spec, which might not be a great design from the start. So maybe we can rethink how we do this in the first place. Not sure we should be doing this anyways.
Yeah, this is another good comment on this problem. It seems that the behavior is more or less the same that we have in AWS. But yeah, I want to raise the attention on this point, and I still need some time to figure it out options.
Thanks for bringing it up. Any other questions or comments for Fabrizio? All right. If not, Daniel, you have the next one.
Thanks, Cecile. Yeah, it's just something I wanted to bring up and see if if there's anybody kind of interested in having a conversation around this. It's the what happens during a cluster upgrade if you are using kubeadm, which I think a lot of us are. So, for example, if you update, if you've got a cluster on 121, for example, and you update the cluster to 122, you start with the control plane. And as soon as you start that update, kubeadm, a new machine running kubeadm 122 will run. It will make some changes that are backward incompatible with kubeadm 121, which is fine according to the kubeadm version SKU. But as a consequence, if you have, as soon as that happens, an existing machine, let's say you have, a worker machine deployment, or maybe more than one, and you want to scale that up, during, it hasn't been upgraded yet, you want to scale it up, or maybe a machine has failed and needs to be replaced. It's going to be using an older, let's say, machine image, one that hasn't been upgraded yet, and so it's going to be using an older version of kubeadm, and it may no longer, or in the case of kubeadm 121, it won't be able to join the cluster, and it just introduces a little bit sort of more maybe risk during the upgrade. You have to think about how the upgrade, while it's in progress, may affect your ability to scale up or replace existing nodes. And just there's just a Slack thread, and then Lumir, I don't know if you want to add anything. I think you might be on the call. There's that link to the update to the wording of the KubeADM SKU policy to, I think, make this more clear than it was before. And, you know, if this is an issue that that affects others, it would be nice to have conversation about this, see what, you know, maybe we can figure out. That's all. Thanks.
Thanks, Daniel. Lubomir, go ahead.
Hi, I was wondering whether the Cluster API maintainers have feedback for this particular use case from Daniel. So maybe you can answer that after I comment. My comment also is that Cluster API in general is doing something that KubeADM does not support out of the box, which is the immutable rollout, node replace upgrades. So if you have something that is a cluster that is created by 125, you want to join 126 nodes to replace the old nodes, this is actually not supported by KubeADM. So Cluster API deals with that by providing a stepping stone, like a boilerplate that mutates the existing cluster to adapt it to the changes that the KubeADM 126 anticipates. That is fine, but this is like the different SKU, which is the N+1 SKU. The use case from Daniel is the N-1 SKU. So I guess you can comment on his particular use case, but I also already pinged Fabrizio and Stefan to have a look at this PR and whether we want to add a specific note about Cluster API or the whole use case around immutable node upgrade, because it's really not supported by KubeADM. We can also have an argument why it is difficult to support. But yes, please have a look at this PR and provide the feedback.
Thanks. Fabrizio, did you want to say anything?
First of all, thanks for raising the point. I think that we are aware that current version management has some flaws. The reason why it is today in this form is that basically we started with Cluster API being agnostic from the control plane and booster provider, and second, there was some limitation in the technology that we were using for implementing validation webhook. So basically, in the first iteration, we were kind of delegating this responsibility to the users. The responsibility to do upgrade, to upgrade all the cluster in the right order, to not do operation while the cluster is being upgraded, stuff like that. I think that now both the technology and also the primitives that we have in Cluster API with managed cluster allows us to step up into in how we do so. So with cluster topology, you have a single point where you have a, let me say, a comprehensive view of all your cluster, and you can also stop operation. Like for instance, I'm upgrading the control plane. Someone asked me to scale up a machine deployment. I can stop him from doing so. I can keep the scaling on hold until the control plane is upgraded and stuff like that. So I think that now we are in a much better position to handle this. It will be great if we start, I know there are issues, for instance, in checking the version, so we don't allow users to specify upgrades that are out of the KubeMin SKU in forward. But this is also another valid use case. We have to start tracking them and try to solve them in a holistic way. So thank you for reporting. It's something that definitely we have to figure it out, how to solve and prevent our user to do invalid operation, basically.
Thanks, Fabrizio. Daniel, Lubomir, did you want to answer anything else on the topic?
No, I think it's great. Thanks, thanks, Lubomir. Thanks, Fabrizio. If there is, if you think it's a good idea to have some kind of roll-up issue for this, then let's take it to Slack. I'm happy to create one and tie the different threads for validation and et cetera together. If we want to document this in the cluster API book, then I'm happy to do that too. But I'd like to, hear some feedback on, on like where and how we should call that out. So maybe take it to Slack. Thanks.
Sounds good. And we actually have a question from Joe in the chat, which I think is pretty accurate. It's saying, what if you're using autoscaler, right? It's not just the user manually scaling. What if you upgrade your control plane and then in the meantime, autoscaler kicks, starts a scale up and a new machine deployment machine tries to join? That would fail too, right? Or any health check that you have going on, Stefan is pointing out, that is doing auto remediation. What happens in that case? Lubomir?
Yeah, I was not exactly an expert around the machine scaling and some of these topics, but I think we had a discussion at some point that cluster API should provide walk-in mechanisms during upgrades, such as that if you are upgrading, you lock the cluster, let it finish. If there is a requirement for remediation, the lock should remain. The user should interfere, fix the problems, the upgrade should continue. Fighting with the autoscaler or another user sequencing machine scalability can be difficult to manage, I think.
So that means we're saying that potentially if the upgrade takes, a while, then during that time, the cluster can't scale up and can't respond to new demand. That could be pretty inconvenient, right? If you're working in a very dynamic environment.
That's what I'm saying.
Joe?
Yeah, we have customers with 5,000 nodes, 10,000 nodes, and them waiting for all of that cluster to be upgraded before they can adjust to demand it's not going to work.
I guess the part I'm confused about is my understanding is that Kubernetes version SKU policy is that your control plane can be, up to n-1 compared to your worker nodes. So why is the kubeadm SKU policy different? Or what makes it that it's not accepting an n+1 control plane?
To clarify, the SKU we're talking about here is not the SKU between kubeadm and a control plane, it's the SKU between kubeadm and kubeadm. So when you create a cluster with kubeadm, some version, and then you try to join a node to this cluster created with the specific binary, the control plane version doesn't matter here. We're talking about implementation details that are present in the cluster, such as a set of specific RBAC rules, for instance, and then the joining kubeadm binary may seek these RBAC rules that are missing. Today, CupBK manages that by manually updating the set of RBAC rules. If you don't have this in the cluster, the joining binary will fail. And I can also emphasize on some of the problems around this, that you might have a security feature in the cluster that the new binary anticipates, but if it's missing, becomes a question of how do we handle this in the joining kubeadm binary? Do we ignore the missing security feature? Or do we tolerate it for another version? And then say, okay, maybe it's missing in this version, but maybe we can add it in the next one. This is, again, the pull request that I'm linking here represents the current state. It's not like we are not defining the policy now, it's just, it is the current state.
Okay, thanks. I'll review that PR, and I guess, yeah, if we want to start a Slack thread or an issue or something to follow up, Daniel, that'd be good. But yeah, it seems like we need to think about the user story here, because it doesn't seem like a very good answer to just tell people, sorry, you can't scale for 4 hours. So yeah, okay. Any last thoughts or closing questions or comments before we split? Okay, if not, thanks everyone. This is a full office hours full of great information. So thank you all for participating, and talk to you all in Slack and online.